Hi all. In this tutorial, we are going to discuss diameter of a binary tree. Prerequisite for this tutorial is just basic knowledge about what binary trees are. So binary trees are basically trees in which each and every node can at max have two child nodes. So what's the diameter of a binary tree is? Diameter of a binary tree is the number of nodes on the longest path between two end nodes. Those end nodes can be any two nodes of the tree and they can be anywhere in the tree. For example, if we see in these two diagrams, in the tree in left, the diameter is 9 nodes. Which 9 nodes? The 9 nodes between the two nodes highlighted with green and passing through the root node of the tree. This is basically the diameter of this tree over which I am hovering my mouse pointer. And if we see in this tree in left, then again diameter is 9 nodes, but not through root, rather it's between these two green nodes, between these two nodes highlighted with green, and I am again hovering my mouse pointer over the diameter. These are basically the nodes which comprise for the diameter. So all these nodes are basically in the left subtree of this tree, not through root. So both the examples, the tree on left and tree on right, in both the cases, we are dealing with the diameter of the binary tree, but in both the cases, scenario is strikingly different. In left tree, the diameter is passing through the root node, and in left tree, diameter entirely lies in the left subtree. Similarly, there could be a case where diameter could be entirely lying in the right subtree. When we are using the term diameter, we must think longest path or path comprising maximum number of nodes. If you check any other permutation combination between any other two nodes apart from these two nodes highlighted in the green, then you would find that nodes between any other two pairs of nodes in these trees would be less than 9, not 9. So now we have to code this diameter function which must return diameter of a given tree whose root node is passed as an argument of this function. So what the first intuition comes to my mind is that diameter, by examples of these two trees, that diameter or maximum number of nodes between two nodes or longest path can be either the diameter of the original tree can either be the diameter of would be maximum of either of diameter of left subtree, or right subtree, or the path passing through the node, like in this example in the left tree, this example. So we can write a recursive function for this. Now, whenever dealing with recursion in data structures and algorithms in DSA, then it's very crucial to first handle all the recursion termination cases. If you won't do that, when you will run the code, your code would get stuck in in an endless recursive loop, and you would get time limit exceeded or TLE error. So when we would terminate the recursion, we would, or when we would start backtracking, when we would reach the leaf nodes or child of leaf nodes, which is basically by definition of leaf node is null. Leaf nodes are defined as the nodes whose both left and right childs are null. So then we would backtrack from our recursion. So for that, I am writing the base or recursion termination condition that when given root reaches to the null. What is meant by root reaches to the null? We would be recursively calling this diameter function and passing the root of the left subtree as new root, or root left of root of this original tree as new root. So when the recursion would reach to the leaf node, then our root would become left or right of root, which would be null in case of leaf node. So if root is equal to null, then we would simply return 0. Now we would need to get the height of the left and right subtree. So I am making a variable L height for the height of the left subtree, and we would get it through another function which I would define as a height function. Basically, we would have to define another height function which simply returns the height or depth of a tree with given root node. So int L height or left height would be equal to height, and we would pass the left of root in this recursive function. Again, this height function is also going to be a recursive function, and we would also need height of right subtree. I'm making variable r height for that purpose. That also we would get by using our same height function, which I am going to define after completing this diameter function. We would need the height of both left subtrees, right subtrees, as well as I explained what the intuition to solve this question is, that our final answer or our diameter of our original given tree would be max of diameter of left subtree or diameter of right subtree, or it would be a path passing through root node. So for that, we also need to get diameter of left and right subtrees. For that purpose, I am defining L diameter to get and store the diameter of left subtree, which we can simply get by recursively calling this same diameter function because purpose is same. This is the beauty of recursion. This is for the left. Similarly, for the right subtree, I am defining a variable right diameter and would call this same function. Now, this very well gives a example of recursion. We are defining a diameter function inside which we are calling diameter function, or we are calling itself. This is the primary example of recursive functions. Now finally, as I explained in my intuition, what would be the diameter of the tree that I'm because we are going to return that at the end of this diameter function. So our diameter of the original tree would be max of height of left subtree plus height of right subtree plus 1. Why this plus 1? This case I am writing for this case of the tree example in this left side. For the case when our diameter is passing through the root. So this plus 1 is to count the root node. Height of left tree would be like 1, 2, 3 for this node highlighted in green. Height of right tree would be 1, 2, 3, 4 and 5. Now plus 1 for this root node. So 3 plus 5, 8 plus 1, 9. But there may also be a case that diameter is not passing through root node, but it lies in either left tree or right tree, right subtree, in either left subtree or right subtree. So our final diameter can be this if in case of passing through the root node, that is height of left subtree plus height of right subtree plus 1, or it could be max of diameter of left subtree or diameter of right subtree. Now with this we are completed with our diameter function. Now as we need to get height of the trees also, so we also need to define a height function. So here I am going to define a height function. Again, this height function is also going to be a recursive function, as I explained in the case of diameter function. That and anyway we are defining recursive function. First and foremost thing we must do is to define a base case termination condition, and here also the case is identical. We are traversing down the tree, so our recursion should backtrack when we reaches the leaf of tree. So I am defining the base case termination condition as when our nodes equals to null. We would simply return 0. Otherwise our height function should return the height of the entire tree, original tree, which would be basically 1 plus max of height of left subtree, comma, height of right subtree. So with this, we are completed with our code. Let's try to compile and run this code. So it's showing compilation completed. Now let's try to submit this code. So problem solved successfully, all test cases passed, and total time taken is 0.8. Okay, so I would be posting this code or would be providing a link to the code in the comments. Do find out. Thanks for watching the video.